Okay, thank you very much for coming today. Um, so today the topic is wireless CSMA with Mikrotik. Okay, my name is Ahmad Mardiansyah. I'm from GLC Networks. Um, yeah, the agenda that we'll be talking today are introduction, wireless CSMA, wireless Mikrotik wireless, some demo, and then QA. Okay, what is GLC? GLC is Garda Lista Cakrawala. We are Indonesian company based in Bandung. Our areas are training and IT consulting. We are Mikrotik certified partner as well as Ubiquiti and Red Hat. Um, about the GLC webinar itself, the webinar first done in January 1st, 2010. So at the time we talk about the Solaris operating system. So we make this webinar as a platform for sharing knowledge. Okay, so it's not limited to Mikrotik only, but can cover many topics such as Linux, networking, wireless database, etc., etc. So our regular schedule is every 2 weeks. The regular schedule is as needed. Please check our schedule at www.glcnetworks.com/main/schedule. So if you want to present something, so you don't need to be an expert, just for knowledge sharing. About myself, my name is Achmad Mardiansyah. I'm based in Bandung, Linux user since 1999, Mikrotik user since 2007, Ubiquiti since 2011, certified trainer for Mikrotik, Ubiquiti, and Red Hat, certified consultant, working as telco engineer, sysadmin, and PHP programmer. Here's my personal website, and then if you want to connect, you can connect through LinkedIn. Right, so about yourself, I think we can skip it. So I think most of you are already familiar with the Mikrotik. So today we'll be talking about a particular topic on Mikrotik, which is the wireless. Okay, especially we talk about the CSMA. So about the wireless CSMA, yeah. So first, before we getting into the CSMA itself, we need to understand the concept of multiplexing. So I have a strong background in telecommunications, and then during my previous work, I was working as telecommunication engineer in core network. Okay, so in a core network, by definition is a network. It's a core, so usually when you draw a topology of a telco network, core usually put in the center because that's why it's called core. So without core, no telecommunication. So core network consists of exchange or switching equipment. So all subscribers connect eventually end up to the switch, and then between switch we have a physical connection between them. And with this multiplexing technique, we can achieve, yeah. So by definitions, multiplexing is a method which can be used by multiple or digital signals, and they are combined into one signal into a shared medium. So for example, we have two exchange A and B, and then between them we have a cable connection, right? So in these cable connections, we apply multiplexing. So the advantage for multiplexing is we can save money. So with that single physical cable, we can send data for more than one subscriber. So several subscribers, will be grouped into one and then sent in the same physical connection. So it can really save money. So I think that's the main how can I say, it's the main motivations why we invented the multiplexing technology. So we can save single physical connection to more than one subscriber. Yeah, so in this case we can increase utilization because we can put more and more customer into one line, right? However, there is a disadvantages for multiplexing. So if you apply multiplexing, then there is no dedicated link for customer. Okay, so if one link goes down, and then many customer will be affected. Okay, because you just only have one physical link, and because many subscriber, many subscribers are put into same line. Subscriber means customer or users. Okay, yeah, subscriber. So subscriber, the service that is offered by a company. Yeah, subscriber service. Okay, so what's called subscriber? So subscribe what? Okay, so there is a question here. Subscriber. What is called subscriber? Subscribe what's like you know, today we have YouTube, and then you have you can subscribe to YouTube channel. Okay, so we call customer as a subscriber because the customer subscribe to a service that is offered by the network provider. Okay, by service provider. Okay, so okay, back again. The disadvantages of using multiplexing is it can lead to contention rate. So as you can see, many if let's say all customer wants to download at the same time, so that one is not I mean the divisions of the resources might not be even. Okay, because yeah, there is a contention rate here. So for example, if you don't have any QoS rules there, QoS implementation on this multiplexing, there will be a customer that is dominating the bandwidth. Okay, so all other user, their connection will be squeezed. Okay, so that was the multiplexing. So next is about the CSMA CD. So CSMA is carrier sense multiple access. CD means collision detection. So it means that it's a multiplexing technique where users communicate to each other using shared media. Okay, so CSMA, yes, CSMA means carrier sense multiple access. So it means that when a host wants to sense, so it's sensing the medium before sending. Okay, so if the medium is silent, okay, and then send. If somebody is sending, so they can sense that, okay, and then collision happens. Okay, so if collision happens, like the picture on the right here, two hosts, yeah, this host and this host sending at the same time, and then there will be a collision. Okay, so if collision happens, and then each host here will retry in random time. Okay, so if random time is reached, and then you can hopefully both hosts will pick a random time, and then the random time is not same. Okay, so the host that has a lower number of random time will be sent first. Okay, so that's how it works. So pretty simple. Okay, CSMA CD is used on Ethernet technology. Okay, so as you can see here, especially if you are using hub, and then of course you are using the CSMA CD. Next is Wi-Fi. So Wi-Fi is a technology that was defined by IEEE with number 802.11. Okay, so the concept is stations will connect to access point in infrastructure mode. So Wi-Fi has two modes. First is ad hoc, which not require the existence of access point, and the second mode is the access point mode. Infrastructure mode. So for infrastructure, which is more robust because there is an access point that controls the access, okay, that controls how the station send to each other. Okay, so that was called access point. That one is easier, more robust. Yeah. So the concept is all station connect to access point. The access point, because like the name suggests, access point, the access point provides SSID as identifications for network, okay, so the wireless network, and then assign a frequency for that one. Okay, so there is no wireless connection without frequency. Okay, so the same frequency is used by all stations to receive and transmit. So with the same with this concept, we can consider the access points as similar to a Wi-Fi is similar to a shared medium. Okay, so because we use the same frequency by all stations to send and receive, so as a consequence, only one host can receive or send at one time. Yeah, so in this case, we can consider this as a half duplex. So in half duplex communications, one sending and the other must wait, okay, until they are finished, and then you can talk. So yeah, it's also another consequence is all stations should be able to listen each other, okay, because we are half duplex, okay, so as a consequence we should be able to hear each other, otherwise there will be chaos, okay. So because I'm speaking, you're speaking, and then the other speaking, well, that can lead to chaos, okay. So you can imagine it's like in a class discussion. So when somebody is speaking, other must wait, okay. If you want to speak, and then you have to wait until somebody is finished what he or she is saying, and then you can speak. Okay, so that's pretty much like discussion. Okay, so, Wi-Fi communication. So Wi-Fi is like discussion. Only one person speak at the same time. All right. So what about CSMA on wireless? On wireless, we call CSMA-CA. So it's a multiplexing technique for wireless Wi-Fi. So CSMA-CA means carrier sense multiple access collision avoidance. Sorry, this slide has lots of text, but at least you get an idea about how the CSMA-CA works. Okay, it's similar to CSMA-CD in some extent, but there are fundamental difference compared to CSMA-CD. So first, step number one. So a station, if a station wants to send, station must sense the medium. Okay, because we know that unlike Ethernet, when a station sending, a station cannot detect collision. Okay, so when a send, okay, I repeat again, when a station sending, they cannot detect if other is sending. Okay, because they can do one job at the same time. They can only do receive or transmit. Okay, I said or, not and, or. But if you are using Ethernet while you are sending, you can still be able to sense the medium. Oh, okay, somebody is sending too. Okay, so at the same time while you are sending, you can sense other sending. Oh, okay, so we have a collision here. yes, you can do it in Ethernet, but in Wi-Fi you cannot do it because that's the nature of a Wi-Fi station. When they are sending, they cannot. When they are sending, they cannot receive. Yeah, because they cannot receive, they cannot sense. Oh, if somebody is sending. So that's why in CSMA we need to very carefully listen the media. So that's why I think the appropriate term is not collision detection. Okay, because why is not collision detection? Because the station cannot detect the collision. So that's why we change the term from collision detection into collision avoidance. Okay, so so we already know why we call it collision avoidance, because we cannot detect collision, as simple as that. And so each station must be carefully listen to the media. Okay, if somebody is sending, they should not send anything. Okay. Next is unlike Ethernet, but similar to TCPs. Okay, so what happens in Ethernet? So when you are sending using Ethernet, there is no acknowledgement on the frame. Okay. Okay, so I repeat again. When you are sending on Ethernet, there is no acknowledgement on the frame. So acknowledgement is done on layer 4, which is TCP or UDP. Layer 4, which is the transport layer, and then transport layer has two famous protocol. There are TCP or UDP. TCP has acknowledgement mechanism, while UDP is not. Okay, so unlike Ethernet and similar to TCP, so we add a mechanism in Wi-Fi where every frame that you are sending, when you receive frame successfully, you have to send acknowledgement to the medium. Okay, I repeat again. After you receive a frame, and then you have to acknowledge to the medium that okay, you already successfully received the frame successfully. Okay, very good. So what happened after that? So because you are sending acknowledgement, somebody is sending acknowledgements. Remember, the first principle of Wi-Fi is every host should be able to listen each other. So when you receive a frame, others can listen to your frame. So when the frame finish successfully, receive successfully, when the frame finish and then receive successfully, and then the receiving host that received the frame will send acknowledgement, will send ACK to the network. Okay, and then when you are sending, when the station is sending, others can listen. Okay, so what's that mean of listening an ACK acknowledgement? So that means the medium is empty. Okay, oh, the medium is empty. So everybody knows, every station knows that, oh, okay, ACK is done, finished, so the medium is empty. Okay, very good. So we can send the data. So how do we send the data? So every station is generating a random time. Okay, they are generating random time and then they are sending. Okay, so hopefully there is no same principle with collision. So hopefully we expect that there is no station that is generating a same random time. Okay, because if they are generating same time, and then there will be another collision. Okay, so hopefully, yeah. So it's like there is a probability that the collision, the communication might collide. Yes, there is a possibility for that. But we expect, but we expect that the random time that is generated is not same. Okay, so the first host that is generated fast will be sent first, okay, and then others must wait, okay. So that's how it works, okay. So they're generating random time, okay. My random time is shortest, okay, I'm sending now. What about others? Oh, okay. They also done their random time, and then when they are sending, okay, others already sent, okay, I have to wait again. So so I have a question here. So there is a possibility that a station is keep sending and sending. It is possible. Yeah, that's what happens in CSMA. Yeah, you cannot really control it. Yeah. So in the picture, CSMA. So unlike Ethernet, Wi-Fi has no collection detection ability. Okay, so with Ethernet station host a computer can detect collision. Okay, can detect collision. They can detect collision, but Wi-Fi they don't have that ability. Okay, so that's why they try to avoid collisions as much as possible. Yeah, with this mechanism. Okay. So unlike Ethernet, similar to TCP. So what's the mechanism? Yeah, so here's the mechanism. So unlike Ethernet, so Ethernet has no acknowledgement, but TCP has acknowledgement. So a station will send acknowledgement here. So this station A, receive packets, receive frames from the access point. So when the station receives successfully, and then this station will send acknowledgement to the network. Yeah, so acknowledgement is sent to the network, so everybody here on this coverage area can hear the frame, because they can hear the frame. Oh, that's the SEK frame. Oh, that means the medium is empty, so we can send. Yes. Okay, so next is about the hidden node problem. So hidden node problem is, as you can see here, so ideally, as I said before, stations should be able to hear each other. Okay, all stations in the coverage area, they should be able to listen to each other. What happens if they're not? Yeah, because the world is not ideal like what we are um, designing in our lab. So there can be many possibilities that all stations cannot hear each other. Okay, so if they cannot hear each other, like this picture, then it can lead to we can call it a hidden node problem, and then which can lead to many collision, as you can see here. So node B here, in the one in the middle, is the access point, and then we have a node A here, we have node C here. So node A and C, yeah, for example here, A and C cannot hear each other, but B can hear both of them. Okay, so because they cannot hear each other, okay, they cannot hear acknowledgements as we discussed in the previous slide. So each stations A or C, they always think, because they never hear the acknowledgement, right? So they always think that, oh, the medium is empty, right? Oh, because the medium is empty, they are sending whenever they want, okay? And then because they are sending like that, this can lead to collision, okay? Corrupted frame again and again, okay? So this hidden node problem is really bad, yeah, for your wireless network. So what's the solution? Well, first is you can apply RTS-CTS technique. Well, this RTS-CTS is not activated by default. Okay, if you buy other equipment, yeah, from different vendors, TP-Link, D-Link, any access point, yeah. So RTS-CTS is not activated by default. Sometimes they just don't put the RTS-CTS on their list. Okay, so if you go, if you buy I think TP-Link it has, but maybe other um, um, vendor, they don't have that RTS CTS. Okay, so RTS CTS, RTS means request to send, CTS means clear to send. So basically the idea of RTS CTS is adding permission mechanism before sending the data. So previously, as you can see here in this picture and the previous slides, when you want to send, you have to listen the SEK. Okay, what happened if you don't listen the SEK? You just send, okay, because you think no one is sending, you just send, okay. But with RTS CTS, you have to request permission. Hello, access point, I want to send something, and then you send RTS. RTS means a permission to send, request to send, and then the access point will receive that RTS, and then if you are allowed to send, and then the access point will send the CTS, okay, clear to send. If the access point approve your request, okay, they will send the CTS, okay, simple as that. Okay. So and another alternative from CTS, RTS, CTS is tdma, okay, time division multiple access. So that means, well, it's similar to the GSM, you know, GSM Global System for Mobile Communication, or yeah, you know, your phone system, wireless phone, mobile phone. Okay, so they are using tdma. So the difference is with tdma, as you can see in this picture. Yeah, I got this picture from Ubiquiti Air Max. So as you can see on the left here, this is the access point, and then the access point is apply tdma technique. So on the left here we have station, we have 4 stations, and then each station, so it seems that we have 5 stations, okay, 1, 2, 3, 4, 5, okay, 5 stations. And then in these 5 stations, each station has its own time slot, okay, so there is no need for sending RTS and then you have to wait for CTS. You already given a time slot, okay, for communication. So I think, in my opinion, tdma is better, yeah, because you already given a time slot, okay. And then here, if you zoom, we can give a priority on the time slot, okay. Right, so that was the hidden node problem. Now let's talk about the several configuration on wireless, Mikrotik wireless. So here, as you can see, wireless setting for Mikrotik, standard settings are like this. Okay, so you just define the mode, band, channel, etc., etc. So this is just pretty basic. So you just define, you are using 802.11. So if you just define like this, okay, you just use a simple 802.11 protocol, as simple as that. So what happened when you have a hidden node problem, and then you need to activate RTS CTS? Well, in advanced tab, you can activate RTS CTS here. Okay, it's very simple. Pick hardware protection mode. You pick that and then click apply, and then you're done. Okay, what happened? What if you have tdma? Well, tdma, it's like this. Okay, tdma period size. So here's the time slot where the where each user get. So this NV2 settings already improved by Mikrotik. Okay, here is the tdma period size, security, and then they also have preset key here. And then in the picture here, as you can see, it's the improvement of NV2, yeah, NV2 settings. So the mode here is dynamic downlink, downlink ratio, sync secrets, and etc. etc. They also put QoS also here, yeah, which is very nice. So I think that's all. Yeah, that is the end of the slide. As you can see, if you are interested, you can join to our training. Okay, just go to our website and then click schedule, and then you will see our schedule. Okay, thank you very much uh, for the webinar. Yeah, we hope you enjoy it, and then see you next time in the next webinar. Right? Oh, if you have any questions, okay, feel free. Okay, any questions here? No, I think my explanation already clear. Thank you very much. Yeah. Well, if no questions, and I think we can stop this webinar. See you again later. Bye.